Look, in periodicity, we are looking at the physical states of chlorides under standard conditions, room temperature and pressure, and oxides also under standard conditions, period three. But be careful, there are some very important ones like AlCl3, PCl5 and PCl3, P4O10 and P4O6, then SiCl2 and S. You have to have this comparison, Al2O3 and this. So first you know these are ionic and they will be a lattice and they will conduct. But see the chlorides, NaCl and MgCl2 are obviously solids. Al2Cl6 is a solid, but you see, if you really want to understand it, you should observe what happens. Like he says that aluminum chloride that have an ionic in solid, but it will sublime and under reduced pressure it will also melt, will turn to liquid. So generally under standard conditions it's sublime. That means it turns from solid to gas. But at reduced pressure, it will first turn to solid, then liquid, and it, it its structure dramatically changes after melting. It actually exists as a covalent bonded in the liquid and the gaseous state. ALCL forms dimers in the liquid. In the liquid, it's a dimer, and in the gaseous state, two data this is of one is this in dimer, and at higher temperature, the dimers also dissociate and exist as individual trigonal AlCl3 molecules in the gas. So remember AlCl3 molecules in the gaseous state, AlCl3 dimers, Al2Cl6 in the liquid state, and ionic lattice in the solid state. AlCl3 exists in all the ways possible. So just see what happens in solid ionic lattice, in liquid dimer, and in gaseous AlCl3 simple molecules. Similarly, so here we have this is in the solid state, so lattice, and SiCl4 and PCl3. Like see, PCl3 is a liquid and PCl5 is a solid. Now, why does that happen? It must be because of the you see, he's saying uh, both are covalent, PCl3 and PCl5. And you know, this is the structure of PCl3 and this is the structure of this dipole van der Waal. And PCl5 is non-polar with only van der Waal. So this is polar, this is non-polar. It has higher melting point than PC3 because of the greater strength of the van der Waal forces between larger PCl5 molecules. As a result, PCl5 is a solid and PCl3 is a liquid. So this is a liquid, this is a solid because of stronger van der Waal forces between the larger PCl5 molecule, more electrons. And similarly with P4, now you see this was the comparison between PCl3 and I was talking about uh, these two. I talked about these and all the states. Now I'm talking of the oxides. The phosphorus also has a two oxides. One is a liquid, one is a solid. Like chlorides, it also has a difference in state of the oxides. P4O10 is solid and P4O6 is liquid. So this is there are two oxides. These are held together big. So this is a white powder, big stronger. The van der Waal force is being stronger. This is a white liquid, waxy. He's saying liquidish due to the larger size. So this has got a stronger this thing van der Waal forces. These are the structures. This is the P4O6 and this is P4O10. This is the solid. This is the liquid, waxy liquid. So these comparisons you should know. Similarly, Al2O3 is a high melting because it's ionic. They're not AlCl3, okay? It's Al2O3. Al2O3. So see the comparison. This is very high uh, melting point and this is very low. So again, compare AlCl3 with this. Then SiCl2 is covalent, but this is covalent network. This is covalent simple molecular. This is a liquid, this is a solid. So again, you can see here that is a giant network of covalent bonds. That means silicon dioxide has a high, in comparison, discrete covalent with van der Waals forces between the molecules. It is liquid under standard conditions. And the others are, these magnesium and all these are ionic, sodium, even the so these, but we see the comparison. I'm comparing PCl5, PCl, relating PCl5, PCl3, P4O10, P410, SiCl2, SiCl4, and SiO2, AlCl3 and Al2O3, and so on. Their structures, their properties. Oh, chlorides reacts with water is another important. NaCl, they ionize, and MgCl2, that will ionize. Once it's ionized, the molecule will be surrounded by the water molecules on all sides. So nothing else will happen. So each chloride is surrounded, it dissolves slightly positive, are surrounded, and the dissolving process involves the dissociation of the and the subsequent assimilation. That means getting surrounded by the ions into the solution. But magnesium chloride also behaves, but it's also because of the smaller size allow and its high charge density. What happens is the coordinate bonds are formed. That means H2O will give both its molecule and form a complex. And Cl minus it will give out. So this will uh, the formation of hexa, and these are able to donate a hydrogen ion. So this is a pH. So the pH will H plus will be coming out. This has resulted in the formation of hexa, which are able to donate a hydrogen ion. So this is slightly acidic. But HCl, if you add a small amount, AlCl3, if you add a small amount, HCl is formed. And if you add excess of water, highly acidic solution. Now what happens is first AlOH3 is formed if you have less water, but if you have more water, again a complex is formed. And this complex further breaks down the water. Water molecules, so the is an it behaves like a Lewis acid, takes electrons, is deficient, and so it breaks down the water and takes the H plus. Uh, what This is the base, it extracts the H plus from this, and you get HT, and you are getting this basically. So it's another acidic solution formed with AlCl3. All the covalent forms, this is what is happening. First, this six compounds of water are surrounding aluminum. All of them are dative bonds. They have given because this is a small with high charge density. Then this water molecule which is around has got a lone pair, and this H plus gets attracted towards this and becomes H3O plus. This acidic is becoming, and you got OH minus. So this now changes to this. So these reactions you should know. The same happens with all the chlorides like SiCl, PCl, PCl5, and chlorine. If you remember H2, you will have HCl. And he's saying even if it's in the water vapor, it is there. The SiCl2 is SiCl4 was a liquid. I showed you. So this. So even the water vapor present in the atmosphere is getting is getting the molecule is getting hydrolyzed, breaking down into uh, reactor. They are hydrolyzed and even reacts with the water vapor in the air to give these vapors of HCl. These are the vapors of HCl. There's water vapor in the air, and this is the SiCl4. So please have this visual memory of these reactions and what's happening on the states, everything.